Hello everyone. Today is the 53rd day of Leetcode 75 challenge. Let's begin with the 53rd question. Question 374. Guess number higher or lower. The level of the problem is easy. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So you are playing a guess game where a number is secretly picked between 1 and n, okay, inclusive. And our goal is to guess the number correctly using a provided API, okay. API will be given to us and a function guess number will be given to us, okay. What will the API do? API will return 0, which means the guess number which we guessed number is basically correct from 1 to n range. Minus 1 if the guess number is higher than the picked number. Suppose if the guess number was 6 and we got 8, then we will get minus 1 because it is higher than the number which has to be, which it used to be, okay. And 1, your guess is lower than the picked number. Basically if it number was 6 to be picked but you picked 4, so it is lesser than 6, therefore the uh, output or the API will return 1, okay. This is the three returns of the API, and you must implement the function guess number which tries to guess the number using a few API call as possible. Return the correct number once found, okay. You can assume there is exactly one correct number within the range. So basically there is this range 1 to n or 1 to 6, suppose, okay. So 1 and 6 are inclusive and you will try to guess the number by passing that particular number in this function, and this number will check and return you the returns 0, minus 1 and 1, which basically means correct, greater or smaller respectively, right? And when we get the number we will return 0, and that is what we have to do, okay. And also we have to try to guess the number using few API calls, means we have to reduce the time complexity as less as possible. Fine. So I hope you understood the problem. It's pretty easy and straightforward, and the constraint of the problems are n is from 1 to the power 31 minus 1, and pick value will be from 1 to n, okay. So I hope you understood the problem explanation and constraints. So let's move to the next slide. Now let's understand the input output explanation. So let's take here, this is n is 10, right? So n is 10, which means 1 2 3 4 5 6 7 8 9 and 10, okay. And we have to pick the number 6, right? So the output will be so what we will do, we will try to search by throwing the number in the guess function, okay. Suppose if we throw 3, it will return what? It will return 1 because it is less than 6. If we throw 8, we will get minus 1 because it is greater than, because that number will be greater than 6, okay. And if it is returned 0, which means the number is equal to the picked number, okay. So here 6 is the output for this particular question example. Now in example 2, n is 1, pick is also 1, right? So it, the range is only this much, so output would be 1. So it's pretty straightforward. And how we will find, we will just throw the random numbers between as you could see 1 to 2 to the power 31 minus 1, right? We'll try throwing that numbers here, and for example 3, n is 2, right? So it will, the range is this, okay. And pick number is 1. So what we can do, we could throw if you throw 3, it is out of the range, right? If you throw 0, it is also less than the range, or the out of the range in both front and back side. And if you throw 2, it is within the range where it is greater than 1, right? Then we'll throw 1 and we'll check, okay, it matches the picked value, so this is our answer. And when the matches, it will return 0, and when we get 0 from the guess function, guess functions returns this value, okay. So we will assume that, okay, we have picked the correct number, or we have guessed the correct number. So I hope you understood the input output explanation, how it's going to be. So let's move to the next slide. Before going to the further slides, let's understand what is binary search, or the concept of binary search. Fine. A binary search is an efficient algorithm that finds a target element or optimal value by repeatedly halving the search space. While commonly used on sorted arrays, it also applies to monotonic functions. Monotonic functions basically means, I will explain that. Okay, let me explain what is binary search. Binary search is basically, if this is a range, right? This is a range. So you keep on doing half of it. Suppose you started here, okay, in the middle, and then you will make the range half, okay. Then you have this particular range with you, then you again started in the middle, then you again make the range half, right? So this way the binary search goes, okay. I will explain in more depth. So So you could see here, it comes in monotonic functions, biotonic sequences, and decision-based problems with a clear true-false boundary. So monotonic functions means increasing or decreasing, which basically means you have a sorted array in clearly increasing or strictly increasing manner. Fine. Or decreasing means that the number is strictly decreasing, 5, 4, 3, 2, 1, whatever, right? So that is a monotonic function. That is a range in which you will use the binary search in a monotonic function. Okay. Then comes the biotonic sequences. Biotonic sequences are basically the first it goes on increasing manner, then it goes on decreasing manner, and then it goes on increasing manner, right? Or it goes in vice versa way. It comes in decreasing, then it goes in increasing, this way. These are the sequences I have given you. Okay. And decision based problems with clear true false boundaries basically just it's way like you have a range and you got a value. Is it equals to the number which we are going to find or not? Then in that case we use this decision based problems. This is just a uh, format of the sequence which you get, in which you can clearly figure out whether you have to use binary search or not. Okay. So it works wherever the solution space has a predictable pattern, enabling us to eliminate half of its at each step. Okay. It has to be a predictable pattern, right? Since monotonic stack is a predictable pattern, biotonic is a predictable pattern, right? So those that's the way it goes. Okay. Now how binary search works, fine, that's the important thing. Suppose let's take a range. Okay. uh, 1, 2, 3, 4, 5, 6. Okay. And start with the entire sorted array. So this is a sorted array, right? Now how it work? We calculate the midpoint. How to calculate the midpoint? 0, 1, 2, 3, 4, 5, right? So what is the low value here? So we have two variables in binary search. One is low and one is high. Okay. And another is mid. Now low takes the uh, index value from the starting, and high takes the index value from the backside, and mid is the calculated value for the particular range mid index. Okay. So low is basically here 0 and high is right now is 5, right? And if we calculate this, how much it going to be? 5 divided by 2, you get 2, right? Okay, you get 2. So this is the mid value right now. Okay. So what happens? You got 2, right? So you come to index 2 here. What is the value of 2? It's 3. Fine. Wait. Now wait. Now the thing is, we compare the mid with the target. Suppose basically we use binary search to find a target value. Okay. So the target value, suppose here is 4. Okay. But you are standing at 3, right? Because you got the mid value as 2. If you could see, if it is equal to the target found, the target is less than the array of mid. Array of mid is the index value, right? And here array of mid, which is array of 0 to array of 2, is the value is 3, correct? And but we were searching for 4 value. The target was to be 4. Okay. Now you could see that, okay, the target value is greater than the mid value. Okay. So what you will do, you will search the right half. Now you will understand what is the repetitively halving the range. Now what will happen? Your low, so low value will come here. Okay. Since I was standing here itself, because this is not the range you need, right? 3 is not required in your search space, because 3, because the value which we are finding is greater than this particular value, right? So we'll make the range here, right? So what will happen? Now low value is what? Low value is 3, high value is 5 right now, and mid value is 2, right? So now what happens? Now you will calculate this mid value again, right? 3 plus 5 gives us what? 8, right? 8 divided by 2 gives us 4. So the mid value for this range is this, right? You come here, 5. Now you will check that, okay, this 5 is greater than the mid value, the target value, right? This array of mid is greater than this target value. Now what we'll do, we will go for the search the left half of the range, whatever you have, right? So what happens in that case, since low was standing here and mid was here and high was in the end, right? Because this space is done, right? We don't require this space anymore, and anything beyond this space is not required also, right? So what will happen? Now L value is 3, right? So 3 plus 4 gives me what? Divided by 2 gives me 7 by 2 gives me 3, right? We get 3. So what will happen? The high will come here and it will stand here. Okay. And mid value is 3, correct? Now what happens? You check. Okay, you will see that, okay, the mid value is 4 and the target value is also 4. Therefore, we found the target. So we then return this particular index, or we return true or false as per the question, right? So we repeat until the target is found or search interval is empty. If the search space says that, you might not have the target, right? And if uh, H comes here and L comes here, because basically they cross each other, that means that the value is not present in the search space. Okay, so I hope you understood that how binary search works. Now, binary search basically works on sorted array, ascending or descending, or bitonic arrays, as I said, or monotonic functions, right? So these are the ways where binary search happens. You have to look for a pattern there. Okay, and why it's efficient? It's efficient because the best case is O of 1 if the middle element is the target, and average worst case is log n. Each step halves the search space. So whenever you do a half of any search space, suppose this is the search space, right? And if you iterate, it will take O of n time complexity. But if you make it a half, you came here and you make it a half, and again you make it a half. So this is a time. This is basically a mathematical calculation. When we do something, and any step, if we make the particular thing in half, 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 like a merge sort, time complexity comes out to be log n, right? So that is why it is much more efficient than any other iteration. And search complexity usually takes one time complexity, and if you are doing a binary search space, then it takes log n recursion stack. That's all. Now this binary search is basically efficient for fast lookup in sorted data, optimizing problems with monotonic pattern, reducing the brute force time from O of n to log n. Okay. Now, where binary search is used. Binary search is basically used in sorted arrays, basic direct applications like binary search question number. This I've just given you the references of the questions also, and where it is used. Right there, this is what this particular PPT is. This slide is all about. So, like first and last occurrence, if you have to find the first and last index of target, right? They find the first and last position of element in the sorted array. These are the questions where you need it. You could go and practice these questions if you want, like search insert positions. If target not found, return the positions where it would be inserted. Example, search insert position, basically you have to insert 7, right? And you got a value 5, you got a value 6, and then 8, right? So 7 will be inserted here, right? So this could be done using binary search. Finding pink element in an array. Peak element comes in the bitonic monotonic bitonic sequence, as I explained earlier, increasing and decreasing, right? So this is will be a peak element, right? Then you have to find the condition why it is a peak element, because the left hand values are lesser and the right hand values are greater than this particular element. Now rotated arrays are also there. Rotated arrays also work as a bitonic sequence. Suppose you had 4 here, 1 2 3, right? So it was a rotated array this way. Modified binary search to handle rotated version. This is question number, you could go and check in Leetcode 33. Cocoa eating bananas or minimum eating speed. This is the most common and most important question to understand binary search on answer, or binary search on answer space, not the array. Answer space is basically you have to figure out by yourself that what could be the range of binary search rather than depending upon the array. Okay, like you have to assume that the search space will be n, or it would be 6, or whatever, depending upon the answer. Fine. So I hope you understood the binary search concepts. Let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem, right? Let's start by understanding the goal first. You are given an integer n and a number is secretly picked between 1 and n. Okay, so 1 and n, any number is picked between this number that will be given to us. So we have access to an API, which is a function, basically guess num, that tells us if our number is too low. If too low, it is 1. If it is too high, it is -1. Okay, it's opposite, and this is 0. Correct. So basically, in the guess API or the function, you will pass a number from this range, suppose 5, and this function will return this any of the three values from this, saying that if it is -1, means that the value which you have passed in the guess function is greater than the value which you have to be picked. Okay, my 1, if the value which you have passed is less than the number to be picked. 0 means is exactly match the number. Okay, now our goal is to find the picked number using the minimum number of API calls. We need to return the correct number once identified. We are guaranteed that a picked number lies between 1 and n. Okay, now brute force. What would be the brute force? Brute force would be try all numbers from 1 to n, one by one, until the guess becomes 0. The time complexity would be O of n. So that so what we can do to reduce it. So this is why this question comes up. Usually this question is pretty easy. You will start from 1 and you will iterate till the n, and in the middle, if you get that value which equals to 0, means they have find it, right? It will take over time complexity, but question specifically says us that we need to our goal is to find a pick, we have to pick the number using the minimum number of API calls, which will reduce the time complexity as much as possible. Okay, so we have to work on that particular thing. So let's visualize the process. So let's imagine the search page as sorted array of numbers 1 to n, right? So let's take sorted space 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and we knew that the n would be given to us. Suppose anything, so n here is given as 10, which is inclusive, and we have to start it from 1. Okay, now suppose the picked value is 6. Okay, I write indexes 0, 1, 2, 3, 4, 5, 6, 8, and 9. Okay, so now what happens, we will be using binary search here. Why? Because we know the brute force solution, which is basically very easy. We'll take a for loop and we will iterate the complete array, and if and we'll keep on passing that particular each value into the guess function, and if it returns 0, that means that you have found the particular value, right? It's pretty straightforward right now, but here we will try to reduce the time complexity by using binary search. So what we could do, how binary search works: low stands here and high stands here, and we have a mid value, right? Now here 0 plus 9 divided by 2 gives me what? Gives me 4, right? 4 is this index, right? So in this left half we have 4 elements, right half we have 5 elements, correct? Now what will happen? We'll pass this 5, this value 5 in the guess function. Okay, now 5, and number which we have to pick was 6, right? Now we could see that 5 is less than 6. What will happen? The guess function will return 1, right? Because the value which we passed is smaller than the value to be searched, 1, right? Now if we got 1, which means that the value which we pass is smaller than 6. Now what happened? We have to reduce the search space. Now what we'll do, we know that since this is a sorted array, any numbers from 1 to 5 will not be greater than 6. Common sense. Therefore any number greater than 5 might be a solution to our problem. Okay, so what we could do, low we could do mid plus 1. Okay, now the range changed from then the low from here will come to here, right? Makes sense, because we know that any number smaller than 5 or equal to 5 will not make any sense. Okay, now we'll do the same thing again. Now this is our search space. As you could see here, we have to repeatedly run around the range as we find a number, okay, until we find the number basically, right? Now in this point, if the guess is too low, we discard the left half, which we did already. Now now here the range will be from 5 plus 9, okay, divided by 2, low plus high, right? 14 by 2 gives me 7, correct? So what is the value in the 7th index? Look for that. It is 8, right? Now we'll pass this 8 here instead of 5 in the guess function. Now since we have to find 6, 8 is greater than 6, so it will return -1, right? If the guess is too high, you have to discard the right half now, because if 8 is there, right, anything from 8 towards the right hand side would be greater than 8, right? So it will not make sense to go and look for the other values on the right hand side, so we have to discard this complete search space. So it happens, we do mid minus 1. Okay, so we discard the complete right part of the search space, and our h comes here. Okay, again, now we have 5 plus 6, which is basically 11, right? 11 by 2 gives me 5, correct? Now mid value is in 5th index, which is 6, and it is equal to the value 6, right? So guess function will return this time 0. Now 0 means what? 0 means that we have found the real value which we have, which we were required to be found, right? So what we will do, we'll return this particular value 6. Okay, and we will break out of the binary search. We continue the process until we guess mid equals to 0, which we got. This ensure that we locate and picked number efficiently. Okay, because as soon as we got like array of mid, right, it would be something like that, right, and the guess function here, and if it is 0, the guess function is return 0, we will do directly return mid. Okay, this way will come out of the binary search. So this is pretty straightforward problem. This is the basic problem for understanding binary search. So I hope you understood the visualization process. So let's go to the next slide. Now how we can simulate this? It will be pretty easy. We would be requiring I, or you could say as L, okay, J, and which you could say as H also, right? The range. And after that, we have to make a while loop, okay, while I is less than or equals to J, because as soon as J and I crosses each other, which means that value is not there, okay, and we have completed the complete whole search space, okay. And in the while loop, what we will do? We find the mid value first. Mid equals to I plus J minus I divided by 2, okay. In Python, we have to give 2 divide marks to get an integer value, and we will check if the guess value, we will pass the mid right here. The index we will pass here. If it is 0, okay, if it is 0, we will just return the mid, okay. Otherwise, what we will do in else if, you will check if guess of mid, if it is equals to -1, which means the value is greater than the picked value, right? So what we will do, we will remove the right search space, and else it is 1, right? Then we will do I equals to mid plus 1, removing the left search space, okay. This way we will do the simulation. So I hope you understood this. Now what we figured out? We figured out that binary search help us to minimize the number of calls to guess API function, and we always halve the search space, making it efficient algorithm. And the logic ensures that we never miss the correct number, and range always shrinks safely and reducing the time complexity from O of n. Okay. So I hope you understood the intuition explanation. So let's move to the next slide. Now, since you got the intuition of the problem, let's look into the approach how we're gonna solve it. Fine. So first we will start by initializing the pointers I and j. This starts the guessing range, end of the guessing range. Basically, this number is somewhere between 1 and n. So we use this as our initial search of bounds, right? I will start from the lower end and j will start from the higher end. Okay. This is a pretty straightforward thing. Now, how we will perform the binary search? While I is less than j, we will calculate the midpoint, right? Why we are doing I plus j minus 1? Because in Leetcode there is a integer flow or out of range flow if you don't write it this way in a bigger numbers, if the range is too big, right? So we sometimes get a garbage value. So if we so we don't get that particular garbage value, we try to write the mid function this way. It's works similarly. 0 plus, suppose n is 8, minus 0 divided by 2, we got 4, right? It's pretty the same thing, just in read code we have to write it this way, so we get the efficient way. Okay, otherwise there would be a overflow or something like that. Now we use the guess mid function API to check. Now whatever value of mid you will get after doing this calculation, we'll just simply pass it into the guess function, and we will wait for the return. If the return is 0, fine. If it is -1, which means that we have picked a number which is greater. It is actually opposite, it will be greater. We'll write it as high, write it as low. Okay, if we got -1, which means that we have found the greater value. So what we will do, we will do j equals to mid -1. Okay, the result is 1. That means we have picked a small number, then it will be mid plus 1. Pretty simple. Now binary search efficiently narrows the range by eliminating half of the remaining numbers on each step, right? This is a pretty simple straightforward thing. Now at the end, after completing the binary search, we will return the result. If we exit the loop, we return 0 as a fallback. So in the context of the problem, we are guaranteed a solution exists, right? But just for our safe case, we put a fallout or fallback. And while returning the mid value, we ensure that we return the correct picked number as soon as we found it. So basically, uh, if the array of mid equals to the 0, then just we return the mid. Okay, that's all. So I hope you understood the approach explanation. Let's move to the next slide. The code is the exact copy of the approach discussed. Let's understand it line by line. So this is the complete function. It's a very pretty and basic question and solution. It's a pretty basic code. So this is the I and j range. This is a while loop. We take out the mid value. If the guess value is 0, return the mid. Otherwise, if it is -1, you have to remove the right search space because the value is greater. If you return, if you do mid plus 1, which means that we will be removing the left search space because the number which we found is less than the value to be found. Okay, and at the end we will return 0 or the fallback. This is a fallback function, but eventually we have a number in the particular range, so this would be the thing. Okay, the time complexity for this particular thing is log of n, and space complexity is O of n. Because why log of n? Because we are using binary search, and since the thing is cutting into half and each in each part, so it reduces the time complexity to log of n. Okay, and space complexity is O of 1 because we are not using any array or any data structure to store the values. That's why. Okay, so I hope you understood the code explanation also. So let's move to the next slide. Now since we have the understanding of the code, let's look at the dry run of the example. Okay, now let's take this example again. Okay, so n is 10, right? So what we will do, this will create a search space. Okay, 4 5 6 7 8 9 and 10. Fine. Now we have to pick a value 6. Now this is done. Okay, I is standing here and j is standing here. Okay, okay, now while I is less than j. Okay, so let me write an index also. 1 2 3 4 5 6 7 8 9. So we'll calculate the mid value first. Mid equals to I0 plus 9 minus 0 divided by 2. So what we get? We get 4, correct? So what happens? Mid value is 4 now. So we will pass the mid in case of mid. Okay, now index 4 is here. Now value is 6. So what will this mid return? This will return 1 because 5 is less than 6. So this will happen. Okay, mid plus 1 will happen. So because of that, I will come here. Okay, this will get removed. Okay, after that we'll go back again. Again new mid value will be calculated. It will be I is 5 plus 9 minus 5. Okay, divided by 2, right? So what will be the output? So the calculation would be, this will give me what? This will give me 4, right? Now 4 divided by 2 gives me 2. 2 plus 5 gives me 7, right? So this mid value has this particular thing now. So this 8 will be passed into this guess function, and what we will get? It will return -1 because 8 is greater than 6. So we will come in this particular part, right? So what will happen? J will be mid -1. So mid value was 7. So mid -1 is 6, right? So what will happen? This J will come to this index. Okay, now again we'll go back. Again the calculation will be done third time. Here it will be 5 plus 6 minus 5 divided by 2. What will the output for this? This will be like 6 minus 5, 6 1, and 0 plus 5 gives me 5. Okay, so output for this particular thing will be 5 because 6 minus 5 gives me 1 and 2 0 0 is 1, right? So this is what we get. So we get 5 as the output. So mid value is this. This will be passed into the guess function and it will return 0 this time because 6 matches the picked value. So we'll return mid, which is basically the fifth index, and so this will be our complete dry run of the problem. Okay, so I hope you understood the dry run. If you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, binary search concept, the approach, and the code. After that, do a dry run by yourself on 2 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. So let's move to the next slide. Now, since you're familiar with the problem and the solution, let's move to the lead code and code the solution. So first, I will declare I comma j, which is equals to 1 comma n. This is a range. Then while I is less than equals to j, mid. Okay, mid equals to I plus j minus I divided by 2, and if guess is equals to 0, we return mid. L if guess of mid equals to -1, we return j equals to, we don't return, we just reduce the search space. J equals to mid -1, else I equals to mid plus 1, right? So at the end we just return 0 for a fallback. Now let's try submitting the sample test cases. Okay, now finally submit the solution. So we have successfully submitted our solution. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.